let's look at debug. The really funny thing, and this still gets me to this date, is every time I start with a new embedded system, the concept of printf, right? We're so used to printf when we learn how to do programming, we sort of take it for granted. Printf, that on a computer, of course, takes a string and throws it out onto your monitor, right? Very, very simple, seems like absolutely a basic function. In embedded world, if you start with a blank processor, the first problem is that you usually don't have a monitor. Okay, so there is no standard out in a processor. And then if you look at what printf does and how it works, it's actually a really complicated function. Okay? The output is simple, like take a string, print the string, but to actually parse that string, especially the number formatting, that's really, really difficult to do. And you can get an idea about this if you look in the IAR project settings. There is a setting to determine what printf can do, because you can do it, but there's a lot of stuff you need to do. So there's a tiny version, a small version, a medium version, and a large version of printf, right? That it can do different things, and that actually is going to have to add code into your system, and potentially a lot of code. Okay? I'm not sure how much, I've never bothered to look into it, but there is something there. It's going to impact the footprint of your code. And then you still have to figure out how to connect it, right? So the processor has no knowledge about sending bits out anywhere. And what usually happens is you'd connect out a UART port and go to a terminal window, exactly like we're doing through the virtual COM port that's connected to our USB. Okay? And that's kind of what we're going to focus on here. But to do that, you have to have a whole UART driver. UART is a serial protocol that's very simple. It's what most computers will speak. It's RS-232 is on the PC side with the, traditionally it's a DB9 connector. We don't see those anymore. Now we just use virtual serial ports. But you've got this bunch of code that needs to work on your system. You've got to have a driver, a serial driver of some sort that it connects to, and then you have to actually go somewhere, right? So that's all the stuff that's involved in printf. Okay? Scanf, if you've used that, is of course the other way, where you have a keyboard and your system in your computer, very simple, of course you read your keyboard and you read some buffer or something as those characters are typed, and magically it appears into your program, right? So enter your name, print out your name. That's one of the first C programs you do, right? Again, we have a big problem with an embedded system. How do we connect a keyboard? Okay, most embedded systems do not have a port of any sort to connect a keyboard. Okay? And then how do we type in those characters? How do we buffer those characters? How do we read those characters? Do you guys know about control characters? I might have talked about this already. This website here, ASCIItable.com, it's one that it's kind of my go-to one, especially when it works. Oh, there it goes. So when you enter a string in your program, okay, that is stored as some sort of binary number. Right? There's no such thing as the letter A as far as a computer goes. It's a hex code or a binary code, and if we look at capital A, in hex it's OX41. Okay, sorry, that's really small. I don't know if I can make it bigger. There you go, it's a little bit bigger. Okay. So you can see all the way to lowercase z, all the way through here. So there's lowercase alphabet, there's the uppercase alphabet, here's all the numbers, here are all the symbols, so everything that you find on a QWERTY keyboard. Okay? Whenever you type a key on a QWERTY keyboard, you actually send a number. Right? You just send a binary code. So if you type the letter A, you're going to get OX41, or whatever that is in binary, 01000001, right? So you'd actually see that. If you put a scope probe on your keyboard, you would see that. Okay? You'd see those characters send, or those bits send. So this, in the old school computer days, when most characters were represented by 1 byte, okay, that gives us 256 characters that we can use. Okay? So this table right now goes to 122. This is called the standard code page, right? So this is universal on all computers. Beyond 127 is a code page that is kind of standard, right? If there's such a thing as kind of standard, but it does tend to vary, especially across Windows or Mac. That's when you get a lot of variations with different languages. That comes in. Of course, now we have something called Unicode, which is at least 2 bytes, if not 4 bytes for encoding characters. And that opens up everything. We can do any language that we want. We can do any sort of symbol. And we have a lot more compatibility between computers around the world. In embedded systems, we tend to worry about our first standard ASCII code page. And that's what we're going to be dealing with. Beyond the characters, from 0 to 30, that's what we call the non-printable characters or the control characters. Just let me scroll this up a bit so you can see them. So if you try to send these to a terminal window, okay, any printable character, you'll actually get the character will come up, right? So we're using TerraTerm as our terminal program. So if you want to send, if you write a string in your embedded system and you send it out with the function that we're going to call debug printf, you can put in a string with printable characters, out it will go, and out it will appear on your terminal program. Okay? But if you send any of these characters, okay, they're non-printable, so they will be received by the terminal, but no character is going to appear. Okay? So in most cases, these don't do a lot, okay, unless you have a computer program or something on the other end that knows how to receive them. A few of them do work. So the first one you can see, OX8 is backspace. Okay? So if you want to clear a character on your terminal from your embedded system, you send OX8, and that will act like a backspace. It'll actually move it'll just move the cursor in the terminal window. Okay. There's a carriage return, so when you press enter, the carriage return and the line feed, OXA and OXD, these are sort of infamous problems that have come. They still haunt people like myself, because back in the day when I first started computers, with Windows and Mac, and this still comes about, when you press enter on a Mac, or I think in Linux also, versus enter on Windows, you get a different control sequence sent. Okay, so I think Windows always sends a carriage return and a line feed, whereas Linux and Mac just send a carriage return. Is that right? Yes, thank you. I knew Maddie would know because she still uses Linux. I wish I did. I let it go a long time ago. So that's actually a huge problem, because if you build an embedded system and it's supposed to work with Mac and it's supposed to work with Windows, you actually have to handle this. And there's lots of things that are buggy as a result of this. So it's a little thing to know. There's null. What else? You can make your computer beep if you send a bell. And that's kind of all the ones that you use, generally speaking. So carriage return, line feed, backspace, okay, those are ones that you'll find that you're going to send, and you're going to actually have to worry about that in our debug exercise here. Null you tend to accidentally send all the time. You can get nice, I think you can make TerraTerm print out hex codes instead of ASCII codes, so you can actually see the hex values coming in if you have some problems. If TerraTerm doesn't do it, there's definitely other terminal programs that do that. So that's an option if you're getting weird stuff. One thing that's really also very important, these numbers, okay, so from 0 to 9, okay, if you add OX30, okay, you can see that you come to 0 through 9 in ASCII. Okay? This is also important, because when you're doing math in an embedded system, you're working with actual numbers, right? So if you take a variable that has been loaded with the number 10 and the variable that's been loaded with number 5, and you add them together and you have 15, but you want to print that out, 10 plus 5 equals 15, you have to take your variable that stores 5, okay? You add 30, OX30, so that you take 5 in decimal and turn it into 5 in ASCII, and then send that. Okay? So doing user interface is a pain. because you always have to manage real numbers that your computer understands or your embedded system understands, and what a terminal program and what people understand because of the way that this works. And this is fundamental to every single computer and embedded system out there, right? So this is like core knowledge that you must know. Okay? So carriage return, line feed, backspace, null, and the act of adding an offset to get from decimal numbers to ASCII characters, and the other way around, right? If you say enter password and the password is 123, okay, that's going to come into your computer as ASCII 1, ASCII 2, and ASCII 3 as a string, okay, or as ASCII characters. So if you want to process that, okay, you have to make sure that you're either going to be aware that you're going to process it in ASCII, or you need to, if you need to do some math on it, you probably want to subtract that offset and do your numbers, and then go back to ASCII if you need to print that out. Okay? So that's some background stuff. Printf is difficult, scanf is more difficult. We're going to roll our own. And that's what I've done in the EIE system. So you're going to see that we have two main functions. So debug printf and debug scanf. Okay. So when I was designing these two functions, I had to figure out what is an acceptable way to do that.
Pretzels now?
Yes, you may. Does anybody else want a pretzel? Ask Adam if you do. So the API that I've created for this, there's a little bit of background about some stuff on there. You can make very, very complicated ASCII and debug type functions. So I kind of did this in a way that uses the least resources possible. It's not something I would probably open up to, a development platform where I didn't have control of it with you guys in the room, kind of thing. And anytime you think about using a global variable that people need to know how it works, that's kind of a flag that, are you sure you want to do this, right? Because that's where you're going to screw up a lot of code and insert a lot of bugs if you aren't working with developers or people that are sort of cognizant of what's going on with that. Okay? So there's two things that or three things that we have here for globals. Okay? First of all, we've got a buffer. Okay? We always have to have a buffer. When we start doing communications, like this is our first time we're doing communications, characters are going to be coming in. Okay? So someone's going to be typing, and those characters are sent to our board. They have to be stored somewhere. Okay? So that's a buffer. Okay? So that global is available that's going to take all those characters coming in. There's a global that's going to be counting the characters that are coming in. Okay, so it gives you a quick way to see how many values are in my buffer, okay, at any given time. So if you're waiting for character input, for example, you can sit there and look at this variable and see if it's not 0. Okay. There's a constant debug scanf buffer size, so that's the total size of there. Okay. So those are the things you need to be aware of. Okay? If you want to use these, because they're defined in the debug.c file, okay, globally defined in there, so they're not static, but you still need to expose them into the file that you're using. So if you want to read from the terminal, okay, in your user task, you need to put these two lines of code. So it's not a redefinition of the variables, but it's a clue to the compiler that these exist somewhere else. Okay? So you use the keyword extern, and by convention, G is for a global, and then I just put in where they came from. Okay? So that's kind of the first trick to using debug printf and debug scanf, these functions. Okay. So here's the API functions. So we've got 6 functions here. So debug printf, that's what you're going to use instead of your usual printf. Okay. This is a totally non-fancy function. Okay. All it takes is a string. Okay. A string in C, remember the only thing that makes an array a string is that it's null terminated, right? So we call it a string. We know that that is likely going to be ASCII characters, and it should terminate in a null. That's how this function works. Call that, give it your pointer to your string, and out will come in your terminal window whatever text you send. Okay, so that's your printf. There's no functionality of doing %d to pick up numbers or anything like that, right? That's really difficult. I have no idea how to make that code work. Okay? One day I might learn. Probably not. If you want to print a number, I built you a function called debug print number. Okay? So you can use these two functions together to print out your strings and print out your numbers. Okay? The maximum that this will take is a 32-byte number. Okay? But how high can you go with 32 bytes? 2 billion if it's signed, 4 billion if it's unsigned. Okay? So that's probably enough, right? And I haven't come across anything that needs something bigger than this. Okay? So if you're trying to print out strings and numbers, you have to use these things together. Okay? There are special characters. If you write a string, JSON, okay, and you want to put a new line in, it's /n. If you want to put a carriage return in, it's /r. Okay? So if you send this this string to the terminal, it will print out JSON and it will move the cursor to the next line at the beginning. Okay? And you can do as many as these want if you want. If you want to write JSON and then 2 lines, you can put in 2 /n's. If you want to write JSON, 2 lines, carriage return, and then JSON again, you can do that. Okay? You can do anything you want in this string. Okay? These characters, these special characters, are just sent as a single control character. Okay? So that's very, very handy. Now, there is also a debug line feed function that I threw in there. All it does is send a string /n/r. Okay? But I did this because you often just need a line feed. So I decided that, because you can inline this if you want, instead of debug printf sending quote something with a parameter, this is a bit more efficient because it doesn't have to pass a parameter. Okay? So that's the only reason that there's that extra debug linef. The trick with these, okay, there is a maximum number of strings that you can queue, and I think it's 24. Okay? So if you need to print a whole bunch of text, okay, and you call combinations of debug printf, print number, and debug line feed, if you call more than 24 of them before they start getting processed through the system.
Daddy,
Hi.
I think that's touched.
Yeah, why don't you try it? So if you have too many before the system starts processing, because you can queue a lot of these inside one of your function calls, right? As your user task is called, you could queue up a whole bunch of stuff. And I've seen this happens all the time. You used to only be able to do 12 of these, and I increased it because people were running into that limit a little too often. So I made it 24. You can make it bigger, okay? But that means that you're going to be kind of hogging memory by this task, right? We only have a certain amount of RAM that we can buffer these things in. Okay? So you choose what kind of makes sense. So if you're having troubles with this, that might be a hint that you might need to give it some time. So if you have like a whole bunch of text to print out, and I think you can send I think up to 256 characters in this, right? So you can build very long compound strings, and you can even use things like if you include string.h, right, that's still allowed. So you can use string cat, you can use string length, whatever other string functions that you want. So you could build compound strings. You could also put wait states in, so you have a whole bunch of stuff to send. You could wait till they get sent, like a certain amount of time. They go fast, so probably like 1 cycle through the system is enough. Whatever. You'll find this as you come across situations that happen to be writing a bunch of strings. Okay? So it's not this bulletproof, perfect system that you're used to writing on a PC because we're resource limited. Okay? So we have to work within this. So that's for getting stuff out. To get stuff in, we use debug scanf. Okay? So you do have access to the global variable where this buffer is. So if you really want to kind of work at a low level, you can pull characters out of this directly. Okay? But that could be a problem. Okay? So more likely what you're going to do is use debug scanf and take that data into your own array where you can process it. Okay? The debug scan buffer belongs to the debug task. You really shouldn't be in there. Okay? But sometimes we need quick access. Sometimes we need several tasks to look at sort of the inputs that are coming in. Okay? If your task is the only system that's going to be looking at input data, you probably want to use debug scanf. You're going to provide your own buffer. Okay? Make sure it's big enough. Debug scanf There's a constant for how big it is, so you might want to just make your buffer that same constant. Okay? If you know you're going to choose less, make it smaller. Okay? Probably doesn't really matter. When you call this function, it not only copies the current buffer, okay, it returns the number of characters that it just copied, right? So if you don't know how many characters have come in, then once you copy it, you'll get back the number of what you just copied, right? Because it could change all the time. You never know, because all the input comes in based on interrupts. Okay? So you could be running a task. Somebody could still be typing. You could still be adding characters to that buffer. Okay? This will safely copy those characters. It clears out that scanf buffer, and it also resets that global character count back to 0. Okay? So once you've got those characters, you can do whatever you want with them. Okay, they're safely in your buffer, and then the debug task goes on and does this thing, and that global variable, the char count, will start counting from 0. So like I said at the beginning, the most efficient way to monitor for input is to look for this character count to go above 0. Okay? Once it's above 0, you know there's something there. You can read characters. Okay? You don't know how many characters you're going to read. Even if you read this and it says 1, okay, by the time you call debug scanf, another character might have come in. Okay, so you always look at the result of this to make sure you got the number of characters that you expect. Okay, and make sure that you have enough size in this buffer to accommodate everything that you're doing. We're going to play with these functions through this task. The other two little things that go on here, and these are kind of new from last year for the guys that have done this before. The debug task, when it's running, when your code starts up, you can see all the startup sequence print out, right? This task is started, this task is started. And then at the end it says you can type en plus c to en plus c00. You can type this in to get a menu. I don't know if you've done that already. Okay. So this is actually a task that's running that's looking for this character sequence. It's a special sequence that's unlikely to just appear. That's why it looks weird. This is Nginx plus C00. Okay, and that'll print a menu. You can enter different commands, en plus C01, 2, 3, whatever that menu shows, and different things will happen to the board. Okay, so that's a task that's running that's using the debug scan buffer. Okay. If you enter a code that's incorrect, or if you enter some other string, that debug task will tell you that you've put in an invalid command. Okay? So now, if you start your own task that's also using debug, that's two tasks using the same resource. So if you're trying to do the assignment, which is to type your name and recognize it, okay, and you press enter, it's going to tell you invalid command, because both tasks are running at the same time. So I added in these two functions that disable the debug task from processing that input. Okay. So if you want to type and just have your task be looking at the input, all you got to do in your initialization function is call debug set pass through. So pass through means the characters come in, they skip, they pass over or pass through the debug task and go right into yours. So that'll take away the appearance of that invalid command message. Okay. You'll see this if this doesn't all make sense. Okay. And if you want to turn that functionality back on, debug clear pass through. So they're just ways to toggle really with just a bit and let your task run exclusively. In this module, do this carefully because it gives you lots of different examples on how to use these functions correctly, and it highlights some of the weird stuff that happens, because there is weird stuff when you're doing characters because it's notoriously weird with control characters and how terminal works. It takes some time getting used to. Okay? So go through these carefully, these examples, step by step, do each one. You should see all the stuff. So there's the EMC plus C00, there's the menu, there's all that sort of different stuff that happens. You can try different functions. If you wanted to, you could program your own debug tasks in here, and I've done that in many designs that I've done, is that I need a standard set of tests to make sure things are going on. So I'll actually program, a backdoor entry kind of thing to be able to give me some programmer access or some extra debug access. So that's what this is. And right now there's just 3 different values for the ASCII board, there's no number 3 here because we don't have cap touch sensors, but those are some basic things that I put on there. So try those out too, so you can actually see what the debug task is doing. There's some stuff specific to the dot matrix board. So go through that. The assignment is to look and monitor that scan buffer in real time. So as you're typing, so you can type random stuff, but if you type your name, so if I actually type JASON, then it's going to detect that and just keep a count of it and print out a little thing that, hey, you just typed your name. Okay? Not pressing enter, and that's kind of the key, right? Pressing enter is easy because you know that something is stopped. Okay? If you're just typing characters looking for a particular string, that's more difficult. Especially if you look at the special cases, the most infamous one is JJASON. Okay. Repeated characters are always a problem, okay, depending on how you write your algorithm. Your intuition to write this algorithm, this will be a bug from everyone that I've seen, because the way that makes sense to write this will be a problem. Okay? But there's other ways to be problems also. Okay? So that's one of the purposes of this exercise, is to make sure that this is that all these different scenarios are being handled. The main purpose is just to understand how you're using those API functions to get those values coming in. Use the debugger. Make sure you're looking at those strings in memory. Make sure you're understanding what the ASCII codes are versus the actual binary values that are being sent, and just get familiar with this. Once you start writing code in larger programs, debug printf, I've got those everywhere to give status about what's happening, right? Just like you've written in your C programs in Windows, you're always doing printfs to see, well, what's going on? Printf, the value of this variable. Printf, the condition that's happening right now. What state am I in? All these different things. This becomes very, very useful. So finally we get that functionality.